Good morning, students. In the last class, we had learned about force. What is force? The type of forces and the effect of forces. Today, we are going to learn about pressure. Take 5 wooden boxes of almost the same size. Fill them with a scrap iron to make them heavy. Arrange these boxes on a wooden table, placing them side by side. See the impact of the push force from these boxes on the table. You will notice that the table remains normal and it is not affected by the push force, that is, the weight of box upon it. But the same wooden boxes, keep it one over the other. So you can see, because of the heaviness of the boxes, the table started bending. Why is it so? You can see in the second picture, in smaller area, the same weight is applied. Whereas in the first picture, the same weight is applied in a larger area. So when the whole weight is applied in a smaller area, the pressure experienced by that area become higher. So that is why the table in the second picture bends. When you hammer an iron nail, you apply force on the flat side of the nail. The pointed side of the nail, which is in contact with the wall, experiences pressure because of the force we applied. What will happen if you hammer the pointed side and try to pierce the flat side of the nail? You see in the first picture, we are hammering on the flat side of the nail and pointed side is piercing the wall. The second picture, we are keeping the nail the other way around. The flat side is kept on the wall and we are hammering on the pointed side. You will find it difficult to push the flat face of the nail through the wall, even if you apply more force than you did in the first case. The reason is that the pressure applied by the tip of the nail on the wall is more than the pressure applied by the nail's flat surface. So in the first picture we can see the pointed side is piercing wall. That means smaller area and greater the pressure. The whole pressure is applied on a small area. And when we keep the flat end of the nail to the wall, the area become larger, but the force applied, even more force applied also, it does not pierce because larger area, when we apply pressure, the effect of the pressure is less than when we apply pressure on a smaller area. So less area in the first picture and more area in the same force is applied on more area. So the area of the tip of the nail is very less as compared to the area of its flat surface. Excuse me. This tells us that the area of the surface on which the force is applied matters. Pressure is equal to perpendicular force divided by area. or perpendicular force upon area. Pressure is the perpendicular force acting on the surface of an object per unit area on which it is acting. So this is the definition of pressure. Pressure is the perpendicular force. Perpendicular means at the 90-degree angle. The perpendicular force acting on the surface of an area per unit area on which it is acting. So on unit area, how much force is applied? That is the pressure. So more pressure, more force, that means more pressure, and also less area means more pressure. So inversely pressure and force are directly proportionate. That means force increases, pressure increases. That means pressure is more, that means the force is more. Whereas pressure and area are inversely proportionate. That means area increases, pressure decreases. Or in other way, pressure is less, that would mean area on which the force is applied is more. That means if the force is same and area keeps changing, that means with the increase of area, pressure decreases. And if we keep the area same and we keep the area same and force increases, so with the increase of force the pressure also increases. So pressure and force are directly proportionate and pressure and area are inversely proportionate. So pressure is equal to perpendicular force N divided by area, that is the unit of area is meter square and the unit of force is Newton. So SI unit of pressure is Newton divided by meter square is equal to P. The SI unit of force is Newton denoted by N and that of the area is meter square. So the SI unit of pressure is Newton per meter square. It is also called Pascal, which is denoted by Pa. Say I keep the force constant and I keep increasing the area. What will happen to the pressure? Will the pressure increase or decrease? If I have a fraction and I keep the term in the numerator constant and keep increasing the term in the denominator, then will the fraction increase or decrease? Let us see. So we said pressure is equal to force divided by area. So if we keep the force constant and if we increase the area, will the pressure increase or decrease? That is our question. See, here we can see we are keeping the force constant, that is force as 7 Newton, and we keep increasing the area. So in the first case the area is 2 meters square, so the force is constant in all the 4 cases, that is 7 Newton, and we keep increasing the area into 2 meters square, 3 meters square, 4 meters square and 5 meters square. So when the pressure is force divided by area. So force is 7 Newton and area is 2 meters square. So the pressure exerted is 3.5 Newton per meter square or pa. So in the case of when we increase the area into 3, the pressure is 2.3, and we increase the area into 4, the pressure is 1.75 Newton per meter square or pa, and when we increased the area into 5, the pressure is 1.4. So from this we can make out pressure keep decreasing when we increase the area. So surely with the increase of area, if the force is constant, the pressure will decrease. So the pressure will decrease if the area increases. The example we saw earlier, the nail and the wall, notice that. So now we got the answer why the flat end of the nail does not pierce the wall easily, whereas the pointed end of the nail pierce the wall easily, because in the pointed end area is less, and therefore when the force applied, the pressure became more, therefore the pointed end pierced easily. Whereas in the flat end, the same force is used. Because of larger area, the pressure is less. The pressure experienced is less. Therefore, the flat end of the nail does not easily pierce the wall like the pointed end. The angle between the nail and the wall is 90 degree. If you notice, the tip of the nail has a very small area compared to the flat surface of the nail, and hence the area of contact with the wall reduces to great extent in the first case. So you can see in the picture, area of contact is less, pressure is more. In the second picture, area of contact is more, the pressure is less. Hence, the pressure applied by the tip on the wall is greater in the first case than the pressure applied by the flat surface in the second picture. That is why it is easy for the tip of the nail to penetrate through the wall than the flat end of the nail. You can even use drill machines to drill the holes into the wall. You see that it has the pointed tip for the same reason. Have you ever noticed that why school bags have wide straps? Why sharp knife cut better as compared to blunt knife? And why the tip of the needle is sharp? In our everyday life, we all experience the impact of pressure. A school bag has wide strap so that the weight of the bag may fall over a larger area of the shoulders of the child, thus resulting in less pressure on the shoulders. And due to less pressure, it is quite comfortable to carry the heavy school bag. So instead of this flat strap, if the strap was thin, then the area of pressure exerted on the body of the child will in that smaller area would be greater where the thin strap touches. So the pressure exerted on that area will be more. As a result, carrying the school bag would have been more difficult for the child. So, as the flat strap exert less pressure on the particular area of the child's body where the strap touches, it is more comfortable for the child to carry the bag. Due to its sharp tip, the needle will put the force on a very small area of the cloth, producing a large pressure sufficient to pierce the cloth being stitched. So, because of the pointed end of the needle, it easily pierces through the cloth because the area is, since the area where the pressure is applied is smaller, the pressure become greater. Therefore, the needle pierces through the cloth easily. Now you can see in this picture the cutting edge of the knife and blunt edge of the knife. So we all know knives have this both side. One end is sharp, that is the cutting edge, and the other end is not sharp, so that is a blunt edge. You can easily cut the vegetable using the cutting edge of the knife. But if you use the blunt edge of the knife, it will be difficult to penetrate it in. Well, in the first sight, the two edges might look the same to us. But if you look at them carefully, the cutting edge has smaller triangles like shapes, which is sharp outer points. The other edge has nothing of these. You can see the close-up of the cutting edge of the knife and the blunt edge of the knife. So cutting edge you see like teeth like up and down, and the other blunt knife does not have. So this pointed teeth like structure reduces the area of contact of knife on the surface of the object or vegetable which has to be cut, and thus greater pressure will be applied on the object which is to be cut, whether it is fruit or vegetable or whatever else is that. Then because of the greater pressure, easily it will be cut. And when the knife become blunt, that means the area of contact with the knife and the object increases. Therefore, the pressure exerted become less. Therefore, the blunt knives does not cut the objects easily. Area of contact reduces, then there is more pressure. So cutting edge has less area of contact, and the other end, the blunt edge, has more area of contact. So if you cut a vegetable with the cutting edge, the area of contact between the vegetable and the knife is greatly reduced. Using cutting edge of the knife, a sharp knife has a very thin edge. It cuts objects better because the area of contact is very small. The force of our hand falls over a very small area of the object, producing a large amount of pressure. And this large amount of pressure cuts the object easily. Axes used to cut the trees also have sharp cutting edges instead of placid ones or blunt edge. It increases the pressure on the tree due to the less area of contact. Less area of contact, more pressure. So, easily cuts. So, these are the examples we have learned for application of high pressure in our daily life. But it is not always the case. There are situations where we require low pressure. Let us see some applications or advantages of low pressure. Advantages of low pressure. We use snowshoes to walk on snow. The reason for that is simple. You can see here the snow shoe with a flat sole. Large area in contact, so it lowers the pressure. So due to the large area in contact with the snow, snowshoes reduces the pressure on the snow. We are able to walk on it without our feet sinking deep inside. You can see the snowshoe and the ordinary shoe. You see the bottom of the snowshoe is larger, the area is more, whereas the ordinary shoe has small area in contact. In case of normal shoes, due to comparatively small area of contact, the pressure on snow is more and it sinks our feet deep inside. So because of less the snow is not hard, no? Snow is soft. So therefore, when less area of contact and more pressure is applied, our shoes and legs sink into the snow. Therefore, walking on the snow become difficult. Whereas with the snowshoes, with a larger area of contact, the shoe and our leg exert less pressure on the snow, and therefore our leg does not sink into the snow, as therefore we are able to walk easier. The pressure on snow is more in the case of the ordinary shoe. We can see the shoes is sinking inside the snow. Force applied on the snow in both the cases is same, but the area on which the force applied is different. So in ordinary shoe, the area on which the force applied is less, therefore more force, resulting in the sinking of the shoe. And in the case of snowshoe, force is same, but the area of contact on the snow is more, and therefore pressure is less. Therefore, the shoe and our leg does not sink. In the same way, as in the army tanks, this is an army tank. It is made up of iron and it is very heavy. And you can see so many wheels also it has. They are also very heavy. And if like ordinary vehicle, if they move with the wheels alone, what would happen? The area of contact is less with the tires, and the army tank is very heavy. So the force applied on the tires will be more, and the area of contact of tire on the ground is less. Therefore, the pressure become more and the tire start sinking into the ground. In order to avoid that, the wheels of the army tank run on steel tracks. You can see that patches like, you know, ribbon like with iron ribbon on which the tire is rolling. So that there, this helps in increasing this iron ribbon helps in increasing the area of contact of the army tank on the ground, therefore reduces the pressure. Thus the tire does not, or the army tank does not sink into the soil and it can move smoother. Wheel on ground, less contact area and more pressure. Steel tracks, the steel tracks around the wheel, you can see larger contact area, therefore less pressure. The army tank is huge in size. If the wheel run on ground due to less contact area with the ground, the pressure on the ground will be massive. However, the track have much larger area of contact. The steel track, the steel ribbon like thing we call it, that is called steel tracks. So because of that larger area of contact with the ground, the pressure on the ground is reduced to great extent. Porters who carry luggages in the railway station and so on place on their head a round piece of cloth when they have to carry heavy loads. By this, they increase the area of contact on the load which with their head. So the pressure on their head is reduced and they find easier to carry the load. So if they had put the luggage directly on their head, the area of contact of the luggage on their head will be less, and as a result the luggage will apply more force on that particular areas, resulting in discomfort and pain. And in order to reduce that, they put a round piece of cloth around their head, and thus luggage apply on those much area of our head the pressure. Therefore, as the area of contact increases, the pressure decreases, therefore less pain in carrying the luggage.